You are listening to Kubernetes Bytes, a podcast bringing you the latest from the world of cloud-native data management. My name is Ryan Wallner, and I'm joined by Bhavin Shah, coming to you from Boston, Massachusetts. We'll be sharing our thoughts on recent cloud-native news and talking to industry experts about their experiences and challenges managing the wealth of data in today's cloud-native ecosystem.
Good morning, good afternoon, and good evening, wherever you are. We are coming to you from Boston, Massachusetts. Today is September 5th, 2024. Hope everyone is doing well and staying safe. Hope everybody had a good Labor Day weekend. Personally, I didn't travel anywhere. I think I learned my lessons a couple of years back that traveling anywhere on long weekends is just crazy. There are always long queues at starting everywhere from the airport to national park entrances to restaurants, trying to find a reservation. And I think 2 years back we decided maybe it's not meant for traveling outside of Boston, but maybe we can travel in New England and just take a road trip somewhere. But that also didn't work out a couple of years back when we were driving back from Acadia National Park, and a 4-hour journey ended up being an 8-hour journey. So yeah, I stayed local, hung out with some friends, played some board games. So that was a fun weekend for me. Hope everyone had a great Labor Day break as well. For at least for the people in the US, right? If you are listening to us from outside the US, hopefully you have a long weekend coming soon, and you can take a break from the day to day. Okay, so today we have an interesting episode. I think with a lot of episodes that we have done this year, it's in the AI/ML theme, trying to present more and more tools that are being built, are being modernized, are being adopted to work for AI/ML or for Kubernetes one way or the other, right? So existing AI frameworks, machine learning frameworks that are now adopted to work on Kubernetes, or new projects that are started with Kubernetes that now also support the AI use case. For this episode, we are talking about the KubeRay project. So we're going to talk about how existing technology around the Ray project can now be adopted using Kubernetes. So to discuss that, we have Kai from Anyscale joining us. He's a software engineer and is an active part of the KubeRay community and active maintainer of the KubeRay project. So I'm excited for that discussion. But before we bring Kai on the podcast, right, a few news items to cover as with our usual flow. I have 3 articles for us today. First one is a fine-tuning example using the Kaito project, the Kubernetes AI toolchain operator. I know that's something that we just discussed a couple of episodes back with Sachi and Paul. But just researching around that episode and even talking to those guys, right, it felt like I didn't know enough about fine tuning. So I was glad when Sachi ended up publishing a blog on Azure's github.io page around how you can actually fine tune language models using Kaito on AKS. It's a great example. We'll link it in the show notes, but it shows you how you can use different more parameter efficient fine tuning techniques like LoRa or low rank adaptation, or QLoRa, quantized low rank adaptation, to fine tune and the Phi small language model with custom data set that's hosted on Hugging Face. So dude, I was so impressed because it makes it look so easy, right? You have a YAML file where you can specify your preset or the model that you want to fine tune. You specify the method, the LoRa or QLoRa that you want to use, and then link to the data set, and then you run that as Kubernetes pods for the actual fine tuning exercise, which takes 2-3 hours for sure, even with the small data set and the small language model. But a great example that helped me learn more. So I thought, let me share it with our community as well. So that's one. Second one is a new open source Kubernetes testing environment from Orca Security. They're a vendor in the Kubernetes DevSecOps security ecosystem. And KTE, or Kubernetes Testing Environment, is meant as an open source, is built as an open source project for EKS, GKE, and AKS customers, and it's designed to help organizations improve their security, Kubernetes security, by providing a safe and controlled space to identify and address potential vulnerabilities before applications are being promoted to production environments. So by using KTE, organizations can simulate various attack scenarios, test security patches, evaluate effectiveness of security configurations and policies, all on these like test dev or staging clusters for their application before actually promoting everything to production. So if you look at their documentation from our show notes, you'll see that they, as part of these deployments, they do deploy industry tools like industry open source tools like the Trivi open source project from Aqua Security. Now it helps with container security or scanning those container images, generating S bombs and things like that. So it I think I interpret this project as making things easier for customers instead of having to deploy these tools manually or figure out how to do it. Maybe do it once through KTE, maybe twice through KTE, and then you can eventually get a hang of like what tools work for you and maybe adopt those. So something interesting to try out. They have like a Terraform module that's available. You can just select which clusters you want to deploy and it deploys it for you and deploys those tools on top as well. And then the final news item we have is something that Ryan and I have discussed in the past, right? I think it was post Red Hat Summit or maybe pre Red Hat Summit this year. It was that Red Hat was working on providing OpenStack as a tenant on OpenShift clusters. So like the ability to deploy OpenStack clusters on OpenShift clusters. And again, when I read it for the first time, it felt weird to me. But then again, if you want to go back to that episode, Ryan and I did have a conversation around how it's just making the process of deploying like day zero operations and managing day two operations for deploying and managing OpenStack clusters easier. And if your organization is investing in OpenShift anyways, and you don't want to use something like OpenShift Vert for deploying VMs, you would rather have like a private cloud environment with OpenStack. That functionality is now GA or generally available. So if you want to try it out, OpenStack on OpenShift is now generally available from Red Hat as a fully supported thing. So those were the three news items. I know it has been a slow summer. I'm hoping that once fall kicks in, once all the conferences kick in, we have a lot more announcements to talk about. And man, I'm hoping that the private market moves and we do see some acquisitions or mergers or even people going public after the market opens. So with that, let's move to the interview section of the episode and bring on Kai to the podcast. Hey Kai, welcome to the Kubernetes Bytes podcast. I know that you are a popular guy this month. I already saw you on a couple of different podcasts, so I'm glad Kubernetes Bytes also made the cut. But for listeners who haven't listened to you on any of the other podcasts, why don't you take a minute to introduce yourself and what you do at Anyscale?
Yeah, thank you. Yeah, my name is Kai-Hsun, and I'm currently a software engineer in the Anyscale. I'm primarily working on the Ray core team, and I primarily working on two parts. The first one is the KubeRay, it's the Ray on Kubernetes, and that's why I'm here. And the other part is that's named the authority DAG. It's a optimization for the Ray to support like the large scale inference and training. Yeah, these are the two current focus for me.
Okay. Awesome. And it looks like you moved to the US sometime recently. What's the background there?
Yeah, I think I previously was in Taiwan.
Okay.
Yeah, and just because I work on some open source project and about the ML platform. Yeah, and I have a chance to know like a Ray and the Spark. Yeah, so I moved to the US to start school and then go to the Database and Anyscale. Yeah, I'm currently in the Anyscale to work on.
Okay, so it wasn't recent. Like it's been a while since you went to school here. Okay.
Yeah. It's been maybe 3 years.
Gotcha. Nice. That's awesome, man. Like you already spoke about or spoke about Ray as the thing that you're working on, and that's why I wanted to do this podcast, right? I saw you were presenting in one of the Ilotil meetups, and Madhuri had posted something about it, and I was like, okay, this is like a topic I was looking for a guest, and you seem like the perfect guest to have on. So I want to pick your brain and learn all about the Ray project, what KubeRay is, how people can use it for their machine learning and AI workflows. But before we dive into all those kinds of details, right? Let's start by talking about like what is Ray, like as a project, like what is the Ray project and how does it fit into like an AI pipeline that an organization might be building?
Yeah, I think you can think Ray is a distributed computing engine for the AI workloads. And I think one of the cool things is that you can think it's similar to like the MapReduce or the Spark, but I think this kind of the MapReduce and Spark are designed for like the data processing workload.
Yep.
So the interface is like the SQL or a map function or reduce function. Yeah, but Ray is designed for the general purpose programming. Yeah, so
Gotcha.
you have a one-on-one mapping with your local programming, like the function, class, and the variable. You can find the distributed version of the function, class, and the variable that's in the array. So it's pretty easy to convert your local scripts into the distributed application with Ray because it has a one-on-one mapping.
Okay. And personally, I got to know of Ray after I learned about the KubeRay project, and then I saw how popular Ray itself has been. So, can you also share some of your thoughts around like what problems does Ray solve for the user, like for anyone using those remote functions?
Got it. I think one of the stuff that the Ray solve is, as I said, that is designed for general programming. Uh, so why do we focus on the AI workload for now? Is because I think AI workload is a very special workload. It includes a lot of different small workloads like data processing, training, tuning, and serving. And each stage you require a different infrastructure requirement. For example, like the serving, you require like to have support auto scaling and high availability. Yeah, and for the training, maybe you need to support like the GAN scheduling. And for the data processing, maybe you require to support like the heterogeneous computation. For example, maybe you need to use the CPU to do some pre-process and then use like a GPU to do the maybe embedding generation.
Okay.
Yeah, so I think a framework that can cover the end-to-end computation is very important. And I think before Ray, I think typically the infra solution is typically built for the microservice architecture. For example, like use some system for the data processing, and use another system for the training, and use another system for the serving. And I think there are a lot of systems very good at the specific kind of workload. For example, like a Spark is pretty good at like the data processing.
Yep.
Yeah, but maybe it is not that good at like the maybe training. Yeah, and for serving, it's like there are like K-serve. K-serve is pretty good. Yeah, but it's maybe not. It cannot do you cannot use K-serve to do the training.
Okay.
Yeah, so so before Ray, that people require to use a lot of like a YAML file or like a lot of pipeline architecture to glue all of the system together, and it will increase the time for the prototyping to production for ML. Yeah, and the Ray, if you use Ray, you can use run everything from data processing to serving. That's in the with the Ray, so you can use a single infrastructure to handle it. So I think that's why users love to use Ray.
Okay. No, I think that makes perfect sense, Kai, right? Because that's why things like Terraform became so popular, because instead of learning how to do infrastructure as code for each cloud provider, like learning CloudFormation and learning Azure ARM, and then learning what Google Cloud has to offer for ISE, instead of doing all of that, I can just use one tool and use it for any operation. So I think that resonates with me, right? Like instead of learning or using different tools, and then it adds overhead for both the actual users, because they have to use different tools for different services, but also on the backend operations team, right? Because now they have to manage and maintain and offer these different tools as services, whereas Ray provides that unified architecture. So no, I think that makes a lot of sense. I had a question though, like you said, this is for distributed computing, right? So in your regular functions, you can specify Ray remote as a wrapper, as a decorator, and it gets executed somewhere else. So can you explain or talk about like what that workflow looks like? Are those Ray clusters already provisioned? How does that work?
Oh, you say how does the Ray cluster provision and how does the end-to-end life cycle? Okay,
Yep.
cool. I think for Ray itself, it provides two deployment solutions. One is on the Kubernetes, and the other one is on the virtual machine. And I think the Ray on Kubernetes is supported by the project and the KubeRay, which is I maintain the project, and I think the KubeRay is a dominant solution for the Ray users to deploy their Ray cluster. Yeah, and I think KubeRay is a normal Kubernetes operator, because I think this is a Kubernetes podcast. I think I assume everyone know what is the operator.
Oh,
and
yeah.
I think everyone knows that. Yeah, so define a CRD and create a CRD, and KubeRay will help you to reconcile the Ray cluster or job or service, depends on your workload. Yeah, so I think this is how it's reconciled. And then we provide different kind of CRD to support a different kind of job. For example, we have the rate cluster to support prototyping, and we have the rate job to support a batch job. And it also integrates with some scheduler like the queue, like the Volcano, like Unicorn. And it also support like the service if you want to serve the model, and it can support auto scaling natively. Yeah. So for a different workload, we have a different deployment solution, and on the application level, Ray built several AI library based on the Ray core.
Okay.
Including like Ray data, Ray train, Ray tune, Ray serve, Ray RLib. And Ray data is primarily for the data loading and like a batch inference, embedding generation. And the Ray train is for the distributed training, and Ray tune is for the hybrid parameter tuning. And the Ray serve is for the for the model serving and to support like the multiplexing model deployment. And the RLib is for the reinforced learning. Yeah. So I think we provide several AI library that's cover end to end, and the Ray is pretty. Ray, if you are using Python, and it's pretty easy for Ray to integrate with the different Python libraries. So if a Ray AI library doesn't cover your use case, you can still. We have a lot of users that use the Ray core itself with their own like the Python dependencies.
No, I think thank you for walking us through that, right? Like I do want to get back to the KubeRay project, and I know we'll focus most of the episode there, but these 4 AI libraries. So do I need to be an expert to use any of these, or these are just Python libraries that I can use? And if I'm building like ETL pipelines and you want to use Ray to do that, the data library helps me do that. Is that the gist of it?
Yeah, I think you can still use the Ray to build your data pipeline. Yeah, to be honest, I think we have some use case for it. Yeah, for example, like Amazon recently moved one of their production cluster from the Spark to the Ray. And the cluster is pretty big. It's exabyte levels. Yeah, so it's
what level? Sorry.
Exabyte.
Exabyte levels. Okay.
Yeah. So I think it's a pretty big cluster. Yeah. So, and I think for a system for infra engineer or for the distributed system engineer, I think Ray is pretty easy to use.
Okay.
Yeah, because I also work on the MariaDuce and Spark before. I think Spark has a SQL, so if you write SQL, I think maybe Spark is very easy to use. Yeah, but I think for MariaDuce, I think I work on I published some paper about MariaDuce before, and I would say that it's not everyone can understand how to write a MariaDuce program.
Yep.
Yeah, so I think compared with that, I think Ray is pretty easy to use in the distributed computation framework. Yeah, but I honestly, I would say that it is still not that easy for a data scientist. I think it is the easiest one, but I think you still require a bit of the distributed system understanding.
Some experience, okay. And I think most of the people that are involved in these AI/ML projects will need to have that as a prereq, right? Like I can't, coming from a non-AI ML background, I can't just open my laptop, install Ray, and expect Ray to like do everything for me. I still need to know how to build those pipelines on my own. So Ray will help me with training and tuning as well, as you mentioned. And this is not just for large language models, right? This is also for what vendors have now started calling like predictive or traditional machine learning. So those predictive models with supervised and unsupervised learning, Ray can help me with all of those models as well.
Yeah.
Okay.
Yeah.
And I had another question. Like you brought up hyperparameter tuning. For people that are listening or hearing about that phrase for the first time, can you expand like what hyperparameter tuning means and how it translates into experimentation and building a more accurate model?
Got it. I think hyperparameter tuning is that because I think everyone, if you have an experience to train the model, you will know that you need to tune like the learning rate or like a batch size. And I think a Ray tuner provides some like the some algorithm that help you to find the best solution, best combination of this kind of hyperparameter.
Yep.
and then you can pick the best one to train your model.
Okay.
Yeah. So but honestly, I think it is not very. I think hyperparameter tuning is not common in the LLM world because I
Yes.
think hyperparameter tuning is too expensive. Yeah, but I think it's common in the traditional ML workload.
Okay. And for LLMs, right? This is me being a novice in this ecosystem. Like I know with the open source models and with Llama, like there are open weight models as well. Like how do they translate? Like can Ray help me manage my weights when I'm working with these large language models?
You say for pre-training or fine-tuning?
Yeah. Yep. Pre-training and
Yeah.
fine-tuning.
I think the one good thing for ray train is that ray train provides our box like the fault tolerant solution for training. Yeah, so I think if you use ray train to train your model and or fine tuning, I think the first one is for the I think the first one is for the fault tolerance, and the other point that I want to mention is about the ecosystem. Because I think Ray train works very well with the Ray data,
Okay.
and Ray data is a very powerful tool for like the data processing and or data loading. Yeah, so I think comparing with like typically if user use like a torch data loader, they need to load the data, run the data loader, do a pre-processing with the with their training workload that's on the same GPU node.
Okay.
Yeah, so and
Gotcha.
they have
then start
some like the data dependency. You need to finish the data processing, and the output data will be the input data for the training step.
Okay.
Yeah, so in the but for the maybe data processing, if we have a GPU on the single GPU node, but the pre-processing maybe only take one single GPU.
Yep.
So the other 7 GPU will be idle.
Yes.
Yeah, but with the Ray data is that you can do the pre-processing that in other maybe smaller GPU node.
Smaller clusters, maybe CPU based nodes as well. Okay.
Yeah. After you finish that, you can stream in the data to the GPU node that you want to use for the training. So I think it will be more cost efficient in this way.
Okay. Nice. No, thank you for taking all these tangents with me. I think this is super helpful for our listeners. So you already introduced KubeRay and how it provides you with an operator and different set of custom resources. Before we dive into it, right, I want to understand why the decision from the Ray community, and you can also talk about why Anyscale is heavily involved in this ecosystem as well. Like, why use Kubernetes as that orchestration layer? What are some of the features between Kubernetes and Ray that are complementary to each other, or is there any overlap that users should avoid or think about?
Got it. I would say at first is that we are in a very early stage of the Ray. We consider to compete or collaborate with the Ray and the Kubernetes. Yeah, because you can see like both of them are the resource orchestrator.
Yep.
But I think the Kubernetes scheduling unit is a part.
Yes.
And in the Ray is the task and the actor, which is a remote function or remote class.
Okay.
Yeah, and then I think finally we decide to just collaborate with the Kubernetes ecosystem. Is because we found that they are designed in the different perspectives. For example, like the Kubernetes is mainly designed for the deployment, so deployment and the operation. So their target customer is like for the maybe infra team, platform team, and maybe DevOps team.
Okay.
Yeah, so all of their APIs like the service for service discovery, for the deployment, upgrades, auto scaling. Yeah, but I think Ray is primarily designed for the computation. So its abstraction is the remote function, remote class, and it's primarily the user primarily is the platform engineer or the data scientist. So I think that's why the Ray community decided to not to compete with the Kubernetes and collaborate together.
Okay.
Because so that the Ray can focus more on the computation side, like integrate with a different like AI ecosystem, and to glue all the end-to-end model lifecycle together. and the Kubernetes, and KubeRay unlock the possibility for Ray to leverage the Kubernetes ecosystem. For example, it's really like we rely on the login system that's in the Kubernetes, like a front bit, or maybe like a CloudWatch, something like that.
Yes.
And we also rely on some observability tool like the Prometheus or Grafana for visualization and for the metrics. And we also rely on some kind of like Istio to do the service mesh. Yeah, and we also rely on a lot of different kind of ingress controller, maybe AWS ALB or something like Nginx.
Yes.
Yeah. So I think it's a perfect collaboration for the different words, one for computation and one for deployment. Yeah, so that's why we decided to leverage the Kubernetes ecosystem.
No, I think that makes sense, right? Because there's no point in reinventing the wheel and figuring out everything that Kubernetes has already solved for in the past 10 years. I know, I don't know if you know this, but Kubernetes celebrated it like 10 years anniversary this year in June. So like 10 years of code base where they have gone through iterations and learned from people running different kinds of workloads, stateless and stateful on Kubernetes, and build some of these platform services. So KubeRay can just, or Ray can basically leverage those. I remember looking at a slide or a session from one of the previous year's Anyscale summit where they were talking about what you just described, like with KubeRay. All the orchestration work is being handled by KubeRay. The platform team can actually be responsible for their Kubernetes clusters and have that separation of duties. And then the data scientists or people that are working on AI workflows can use all the Ray functionality. So it allows people to do their job while at the same time leveraging the benefits of both platforms. So now I think that makes total sense. So you said there is an operator, right? Like, so how do I deploy it? Is there a specific I know you said it works with CPU and GPU, but are there specific resource requirements? What are some of the steps that I need to follow to get KubeRay up and running on my cluster?
I think it's pretty simple. Yeah, because I think I think KubeRay operator is just a single pod.
Okay.
And maybe I think I typically use maybe just one or maybe 0.2 CPU, something like that.
Oh, perfect. Nice.
Yeah, I think for some like a local deployment. Yeah, and you can try, and I think we provide a lot of example on the Ray website for the example. And on your laptop, you can try to for example, do some batch inference, and or for you can train some model. If you only have the CPU, you can train a distributed training and with MNIST with the CPU, very simple.
Yeah.
And you can also serve the model with a mobile net for the image recognition on your laptop. And so I think I typically when I demo, I just use the local Kai cluster.
Okay.
So
perfect.
I think it's pretty lightweight. And I think if you use a GKE, I think a GKE also I think KubeRay is also I think maybe the one, and I think maybe currently is still the only one AI work on AI add-on on the GKE cluster.
Okay.
So you can just click a button and the GK will help you to launch the KubeRay operator.
Okay, that's awesome.
Yeah, and I think or if you also want to try Ray, you can just use the Anyscale. Yeah.
Okay, perfect. So you said there are also some CRDs, and we listed like Ray cluster, Ray job, Ray service. Can you expand more on what each of these CRDs mean and what functionality can users expect? By Ray cluster, I assume it's some kind of a cluster. So can you talk more about what each of those CRDs mean?
Got it. I think the basic CRD is the Ray cluster. I think it's just a long running cluster, and it helps you to make sure your cluster is healthy and launch the head node and the worker node and connect them together. And it also supports the auto scatter. Array has their native auto scatter.
Okay.
And so if the workload is if a array scatter detect that the resource is not enough, it will notify the KubeRay to scale up the cluster. Yeah, and it also provides some like the fault tolerance for
Yes.
our metadata. Yeah, so I think that's the Ray cluster works, and typically it is mainly designed for the like a prototyping.
Mm-hmm.
Yeah, and I think some user use it for multiple user to submit their job to a cluster, to a single cluster. Yeah, but I think currently is that I think a multi-host, multi-tenant is still something that we are currently focusing on.
Okay.
Yeah, but currently is that still have some feature gap.
Yeah. No,
So-
no, I think like even with Ray cluster, right? Since it's like it's a CRD, if I want to create a Ray cluster for 8 hours, I can do that and then delete the custom resource object from my Kubernetes cluster, and it because of the way Kubernetes works and control loops work, it will delete all the resources and somebody else can spin it up. So I know multi-tenant Ray clusters are a huge feature request, but I'm assuming that the ability to provision and deprovision resources on demand also helps. One question, right, before we move on to Ray jobs and Ray service, the different AI libraries that you mentioned, data, train, tune, and serve, all of those will work with Ray cluster, or is there a specific customization I need to apply in the YAML file to use it for one type of a library or another?
Yeah, I think it will work with the Ray cluster if the cluster have the computing resource that you require for the computation workload.
Gotcha. Okay. No, I think that's awesome. And you said Ray itself, or KubeRay itself, has like an auto scaling functionality where it monitors utilization, and if it needs more worker nodes, it will spin those up. Does it add? Is this already a supported scenario, or like if my KubeRay operator is deploying more and more of these worker nodes for my Ray cluster, at some point my Kubernetes cluster will run out of resources, right? So are you also working on integrating with projects like the Carpenter project that AWS open sourced, or some other form of Kubernetes auto-scaling principles, or that can help me make sure I have enough capacity on my Kubernetes cluster for these Ray pods to be deployed?
Got it. I think typically when user use the Ray auto scaling that's in the with the KubeRay, I think typically they will also use like a Carpenter or GKE autopilot
Okay.
to auto scale their Kubernetes node.
Okay.
I think there are
Perfect.
several levels of the auto scaling in the Ray. The first is a Ray scheduler will monitor the like a Ray task or actor, and then it will launch a new actor or task. If for example like a serving, if a serving that has received a lot of requests, it will scale out a new Ray serve replica, which is a Ray actor.
Gotcha.
And then if the Ray scheduler found that it doesn't have enough resource in the Ray cluster to schedule this actor, it will trigger the Ray autoscaler to tell the KubeRay to create a new pod. And then I think maybe a GK autopilot or a Carpenter found that there's no enough resource for this Kubernetes pod, and it will trigger the auto-scaling to schedule a new Kubernetes node.
Okay.
So they are the different level for auto-scaling.
Okay. No, that's awesome. That's great to hear, right?
I think it's a good question.
Yeah. What about Ray job? Like, what does it do? How does it help users? Can you talk more about that now?
Got it. I think for the Ray job is that it is also based on the Ray cluster CR under the hood. And the other thing is that it will help you to manage your application lifecycle.
Okay.
For example, we also integrate with like some Kubernetes schedulers. Like we also integrate with like Q or like a Volcano or Unicorn to support like the Gantt scheduling and the priority scheduling. Yeah. So it will create a cluster and submit a job to the cluster, and it will monitor the status.
Okay.
And when the job finish, you can have some configuration to maybe clean it up or or something. I think it's pretty similar to the Kubernetes job API. To be honest, I think when I just want to make sure like the Ray job have the same API with the Kubernetes job. So honestly, I just copy like the Kubernetes job has this feature. I just copy to a Ray job. But you can see it's like it's manage a cluster, and the Kubernetes job is manage a pod. Yeah.
Okay. No, I think that makes sense. So instead of in when we were talking about Ray cluster, I was thinking about users provisioning and deprovisioning Ray clusters and the resources. I think Ray job is a better abstraction layer. Like if I want like Ray to do something for me or run some functions, I can just define it as a Ray job. It will automatically provision the cluster underneath it and remove all the resources once it's done. Okay. So what about Ray service? Is it also an abstraction? Like, how does that work?
Yeah, I think a Ray service also depends on the Ray cluster.
Mm-hmm.
And first, it will create a Ray cluster and then deploy the server application. And it will control which node can receive the request.
Okay.
So because it depends on because Ray server also have their auto scaling, something like that, and I think KubeRay handles the route of the request.
Okay.
And then it also handle as I said, the fault tolerance of metadata, because I think in the online service you require the high availability.
Okay.
Yeah, and the other side for Ray service handle is that it handles upgrade. It's currently provide a blue-green upgrade.
Okay.
Yeah, but I think currently we are also have a lot of discussion about a rolling upgrade.
Okay. So a couple of questions around that, right? So let me start with last in first out. So upgrades, are Ray clusters or Ray jobs really that long running where I have to worry about upgrading the version of Ray? Isn't it just deployed once, run maybe it for 8 hours, 2 days, whatever, but then it goes away? I don't have to worry about 3-month long run where I have to worry about Ray version updates. Is that a possible scenario? And that's why we need some kind of blue, green or rolling updates?
I think the current is that I think for Ray job is that typically people don't worry about the upgrade because I think a single job is only for in a Ray job. I think a single cluster is for only a single job.
Okay.
So you if you want to upgrade your cluster, you just need to submit a new job.
Yep.
Yeah, and I think for Ray cluster is that because as I said that we currently, I think we currently still have something that we need to support for the multi-tenancy. So typically currently is that is for the single user for prototyping.
Yeah.
And for single user for prototyping, it's pretty easy to coordinate that to shut down your cluster and launch a new one.
Yep.
Yeah, and for the Ray service that because I think currently. Yeah, to be honest, I think currently the Ray doesn't have a very good story for upgrades.
Okay.
Yeah, to be honest, because I think the Ray head and the worker are very sensitive in the version mismatch.
Okay.
So you cannot upgrade the worker part to maybe to a newer version.
Yeah.
And connect to the old version of the Ray head.
Yeah, you're basically creating a second cluster itself, and then
Yeah, so we currently that's required to create a new Ray cluster.
Okay.
Yeah, so that's why we support a blue-green upgrade for now.
Okay. And for Ray service, right, is it the name makes me believe that this is for model serving? Is that the case? And that might be the reason why it needs upgrades because it's a long-running thing, right? Once you have deployed an inferencing setup, you need that service to be around.
Yeah.
Okay.
That is
okay.
Correct.
Gotcha. Okay, I think then the upgrade scenarios make sense. Thank you. Thank you for walking me through all of that. Next up, I think I want to know if KubeRay can help me deploy LLMs on my Kubernetes cluster and use those as part of my applications that are running on Kubernetes. And the reason I asked this is we had folks from Microsoft who are working on the Kaito project, Kaito, the Kubernetes AI toolchain operator. And they allow me to run not only Microsoft tested and validated language models on my Kubernetes cluster, specifically AKS, but also it gives me the ability to package up my own custom fine-tuned models and deploy those on Kubernetes. Can KubeRay help me with that as well? If I wanted to download models from Hugging Face and deploy it on Kubernetes, can I use KubeRay for that scenario?
Yeah, I think it's primarily for a Ray question, and I think for Ray is that if you use I think if it has a Python support, I think you can definitely use the Ray to do that.
Gotcha. Okay.
And you can use the Ray server to serve it, and KubeRay provide a deployment solution.
Okay. Yeah. Okay. It makes more sense. It is like that platform layer. If I for remote execution and distributed computing. So if Python can do it, I can use Ray for that remote execution. Okay.
Yeah, and we have some example about the VLM with the Ray server on the KubeRay. Honestly, I think the doc is currently under review. Yeah, and
Okay.
and I am currently also looking at the project and the S3 then. Yeah,
Okay.
I think it is also an alternative of the VLM. Yeah, and I think one of the good things for the KubeRay for Ray and KubeRay is that I think maybe I'm not sure, but I think maybe KubeRay is maybe the current only solution uh to support like different kind of auto scaling, including like a multi-host accelerator and a single host accelerator.
Okay.
Like we
Okay.
currently support like a multi-host TPU.
Oh, wow.
Yeah,
Okay.
and I think currently don't have a. I think currently in the open source world don't have a very flexible way to scale up the multi-host autoscaler,
Oh, yeah.
multi-host accelerator.
Are you also working on similar things for other clouds? I know AWS also has their Trainium and Inferentia chips, right? So, is the KubeRay community also working on integrating with those?
Yeah, I think the Ray work with. I think there are some like folk from the AWS to integrate with Trainium and the Inferentia that's with the
Okay.
Ray. And I
Okay.
think it can. It doesn't require any update from the KubeRay side, and it can work all bugs.
Okay.
Yeah,
That,
but
that's
I
that's
think
good to know. Yeah.
yeah, but I think currently it doesn't have the multi-host accelerator.
Okay.
Maybe in my current understanding,
Okay.
I'm
No
not
worries.
pretty sure.
Yeah, no, thank you. Thank you for being honest and not making things up. Okay, so we already spoke about like the ability to use Ray for things like pre-training and fine tuning. And with KubeRay, assumption is since it's just a way to deploy things on Kubernetes, those operations are also supported. Is that correct?
Sorry, can you say again?
Can I use KubeRay to pre-train LLM models or fine-tune models on top of Kubernetes? Can KubeRay help me with that?
Yeah, I think this is. I think KubeRay is a deployment solution, and I
Yes,
think Ray provide a computation
those
solution.
functional.
Yeah, I would say that. I think some user just pre-train their model that's on the with Ray. Yeah, but let me think. I think maybe I can mention that is that because it is a public, there are public news is that I think OpenAI GPT 3.5 and GPT 4 are on Ray.
Oh
Actually, on
wow,
Ray.
that's
I,
good information. Yeah,
I
nice.
think there are some public press
Yeah, yeah,
about
yeah.
that.
And I think OpenAI has been good in terms of talking about their usage. Anyways, like I still remember, like they did a session back at KubeCon 2018 or something around their use, even when nobody was. I think they were talking about how they trained GPT-1 maybe on Kubernetes, and I know they have a good tech blog. So yeah, I'm sure that information is out there. Okay, and I think my next question was around day two operations, since we spoke about day zero and what those CRDs mean. But I think we already covered things like upgrades, rolling upgrades, and the community is working on rolling updates instead of just blue green, and then auto scaling and how that works. Any other like day two operations, like is the KubeRay community involved in managing those container images or the images of the like the Ray cluster that get deployed, and how is security handled and security vulnerabilities and CVEs handled as part of that community? Is that all part of the community, or is there a vendor that provides these images?
I think for the KubeRay image itself, I think it's maintained by the KubeRay community.
Okay.
I think we have some like a dependent part, and we have some partners
Mm-hmm.
in the community. I think they will run their like the some kind of the testing, and
Okay.
yeah, I think I think we focus a lot on this kind of stuff. Yeah, and I think for Ray side that we have the Anyscale side have the security team to focus on that.
Gotcha. Okay. And how do all these things work with storage? Like this, so I don't know if you know this, but Ryan and I started this podcast as like a Kubernetes storage focused podcast, and hence a
Oh,
like cheeky
really?
name, Kubernetes Bytes. So we do bring it around to like storage features, right? So when I'm deploying a Ray cluster or a Ray job or a Ray service, what kind of storage do I need? Is there like a certain PVCs that get provisioned? I know we were talking about like the Ray data library and how it stores, like it pre-processes data and stores it somewhere. When I'm using or doing those operations on Kubernetes, Are these stored in like persistent volume objects, and it just works because Kubernetes APIs work across any distribution?
Yeah. I think it support like every kind of the Kubernetes API because we just expose the path back to the users. And I
Okay.
think typically maybe I just use maybe like a S3 bucket or like a GCS bucket
Okay.
on a different cloud, or like sometimes we use something like a shared file system like the EFS. Yeah, so I think it
Okay.
depends on the use case.
Okay, but there is the possibility that if I wanted to use like read write many persistent volume for that shared file system, I can use Kubernetes objects.
Yeah.
Okay, perfect. No, thank you for walking us through that. Since you have been involved in this community, right, I also wanted to throw in the question around any customer examples that you can share. I know I've seen the talk that I saw from last year. It wasn't around KubeRay specifically, just around Ray. I saw Uber as one of the customers using it. Do you have any stories that you want to share of a real world example using KubeRay for their ML workflows?
Got it. I think maybe I can share some example. For example, like maybe the first one is like from the Sensara. I think they also published their blog about they use the reserve to do a model serving.
Okay.
And I think at first is that in their blog they said that they have at first they have some microservice, maybe one for the Golden, and the Golden do some like maybe model selection and then send to a Python microservice to do some inference, and then the inference result will send to another Golden service to do some business logic.
Okay.
Yeah, and then they use Reserve and the KubeRay to write all the logic together in the array, and then so they can reduce the overhead between the serialization and deserialization between the different microservice.
Yeah.
And then they can share the resource between the different stage. And I think the blog post that they save the 50% of the cost about that.
Okay, no, that's a great use case. Just streamlining model serving. So, since you said this is like a public reference, we'll have like show notes. We'll have those links in the show notes. So, if people want to learn more about how they're using it, and I can include it for people to learn more about it. So, no, thank you for sharing that. Right, I think that brings me to my like a couple of last questions. One is definitely like the last one. I want to keep it around, but I want to bring it up. Like, are there any things that I haven't asked that users should know about around the KubeRay project, or we have pretty much covered the basics here?
I think the best way to just know the latest news is that just join the Ray Stack channel, and
Okay.
and I think I will monitor the channel, and some of our community folks will also monitor the channels, and it's the best way to reach out to us. Yeah, and I think we are very active on that.
Okay.
And I think maybe the second one is that maybe you can we have a conference recently in the I think maybe in the September 30 is a Ray Summit in the
Okay.
SF. Yeah, so I think a lot of our users will give the presentation, on the conference, and we will have host some some get together, yeah, to just meet with some like a contributor or Ray users together.
Oh, that's awesome. That's like perfect timing for this podcast, right? Like it's September
Yeah,
30th, you said. So people listening to it this week can actually go and register for it if they are in the Bay Area or if they want to travel to the Bay Area. Okay. That's awesome. In addition to the Slack channel and the Race Summit, are there any other resources, documentation links that you want people to go and read through if they want to learn more about KubeRay and Raycore?
Oh, I think maybe you can go to ray.io. Yeah, this is the Ray official website.
Okay.
Yeah.
Awesome.
Yeah. And if you have any KubeRay question, you can just open an issue that's in the KubeRay repository.
Okay. Perfect. Yeah, we'll make sure we'll include all of those links in addition to like the GitHub repo, the ray.io, and the conference registration website. Awesome. Kai, if you don't have anything else to add, I would like to thank you for joining me for this episode of the Kubernetes Bytes podcast. Right, I had a great time learning about Ray. All I knew about KubeRay and Ray was that 20-minute session that I saw from last year. So I appreciate you spending this time with me.
Yeah, cool. Thank you for your invitation.
Awesome. I think that was a great episode. I learned a lot. I loved how Kai went into all kinds of details around how all the different Ray libraries work. What are all the CRDs? I know we ended up spending a lot of time diving into CRDs, but I think that's the best you can do in a podcast format when you're not sharing your screen and showing CRD objects. I think just talking through the different reasons of why have these different CRDs in the first place. What do they represent? How do they help a user or an organization? What does the provisioning and deprovisioning or cleanup process look like after the fact? How do upgrades and auto scaling things work from a day to operations perspective? So I love all the level of details that we went into. I think Ray is definitely an interesting project. If you go to ray.io, as Kai mentioned, you will see that they have a lot of these enterprises that are already using Ray. Now it's just with the KubeRay project, everything is more streamlined. The Ray audience can now use the benefits from Kubernetes. One of the things I remember from some of the pre-work that I did before the podcast was whenever administrators or IT teams were deploying Ray clusters for their data scientist teams, the underutilization of resources was a really big deal, right? Like they were deploying Ray clusters on GPU nodes, and they were not being utilized for 24 hours a day. Like they were just sitting around for the next tenant and the next tenant to maybe use it and run some jobs remotely. With KubeRay, right? I think the whole thing that you can solve is you only provision a cluster and the resources when you need it, when your job is done, or when you're when data processing or model training or fine tuning or serving, all of these things are done. KubeRay can automatically deprovision all the resources that are deployed, so it helps with that resource efficiency. All the same benefits that we talk about when you talk about applications running on Kubernetes, right? So I think there is huge value there. I'm excited for the Ray Summit that Kai brought up. I don't think I'll be able to attend in person, but I'm definitely looking forward to the recordings from that session and see what interesting stories, customer stories, come up this time around. Kai did have an interesting nugget for us. So if you use the promo code that we'll have in our show notes and with the link to register, it's on September 30th. We have like a 15% discount. So if any of our listeners want to learn more about KubeRay or see how the community is using KubeRay and Ray, and you are in the Bay Area and want to attend a day-long conference, use the link. It's not something that's specific to Kubernetes Bytes, just something that's specific to Kai. So I appreciate him sharing that with our listeners. But with that, I think those were my key takeaways. I want to reiterate the fact that please make sure you share this with at least 2 more people. I think that's how we can get to the growth stage that we expect. But please give us 5-star review, subscribe to our YouTube channel. I know our YouTube audience is increasing bit by bit every day. Every day I see more listeners pop up. So that's like a dopamine hit that I take. I get every morning when I look at the stats. So even if you're an audio listener, which is way more than what we have as our video subscribers, please go to our YouTube channel. Just search for Kubernetes Bytes on YouTube the next time you are on and hit that subscribe button. I think that will help us a lot. Getting feedback from all of you is great. So if you have anything you want to share with us, go to our website, kubernetesbytes.com, join our Slack community, and just feel free to ping us or reach out to us. No, that's it. With that, I want to, that brings us to the end of another episode. I'm Bhavin, and thanks for joining another episode of the Kubernetes Bytes podcast.
Thank you for listening to the Kubernetes Bytes podcast.